Hi everyone. Let's take a look at today's lesson's topic. Hey, solution stoichiometry. I remember that. And hopefully it doesn't give you nightmares, me talking about stoichiometry, but yeah, we're talking about solution stoichiometry. The last time you looked at stoichiometry, you were given this equation. Okay, you even, I guess, did an experiment dealing with this equation. You even have a lab report based on this equation. Yes, this was the chalk making lab. Remember you took calcium chloride, you dissolved in water. Remember you took sodium carbonate and you dissolved that in water, and then you mixed the two together. Do you remember doing that? And then you took an apparatus called gravitational filtration apparatus, really just running it through a filter paper and collect calcium carbonate as a precipitate. This is chalk. And then you weigh this chalk and you find out what the percent yield was. Remember that? Yeah, that was great, wasn't it? And what did you do with the NaCl? That's right, you really just chugged it down the sink like it was like yesterday's garbage. And it was, because that's not what we were asking to find. This is not our target. It was the chalk. Well, let's say today we're talking about solution stoichiometry. This is a solution. NaCl was a solution from this reaction. What if I asked you, what's the concentration of this? Maybe it wasn't a good idea to chuck that down the sink after all, but it doesn't matter. Okay, it really doesn't matter. You add so much water into this. Remember you have these, when you have the beaker, and then there's all these like calcium carbonate stuck on the wall of the beaker, and then you put a whole bunch of water in here to wash it all off, to put it into the filter paper. Remember doing all that? If you did, great. If you don't, or you haven't done it yet, don't worry about it, because you will have the opportunity to do this. Yeah, you put so much water in it, it gets so diluted anyways. But let's say you didn't, and you were to find out what the concentration of NaCl was going to be. That is solution stoichiometry. And that is the first example that I want to do with you today. Okay? So I have right here a certain concentration of calcium chloride. So 3 molar of calcium chloride at 300 milliliter. Sodium carbonate, I have 2.9 molar at also 300 milliliter. I'm going to mix the two together. And then I want to know, what is NaCl in terms of concentration? Okay? Now, the whole idea, of course, is that concentration is equal to the mole of NaCl divided by the total volume. That's what it is. I want to know two things. I want to know, what is the total volume, which is pretty easy, by the way. And I want to know, what is the mole of NaCl, which is not hard, by the way, because you know how to do stoichiometry. Stoichiometry is all based on ratio, the mole ratio. Okay? And the ratio here is 2 to 2. You just need to know which one to the 2. Now, it's going to be 1 to 2 for sure, because both of these are 1. But which one are you going to use? Are you going to use CaCl2? Or are you going to use Na2CO3? Because you're given both. So let's do that thing that you guys all love to do and find out who is the limited reagent. So let's do that. Before we do that, we might want to find out how much mole is in here and how much mole is in here. Okay, so that's 3.0 moles per liter times 0.3 liters. Okay, so that would be, I am breaking up my calculator because I'm too lazy to calculate that in my head, even though it's so simple. So that's 0.9 mole. Here, 2.9 moles per liter times 0.3 liters. And that is going to be, this 0.87 mole. Okay. If you want, you can change the grams, but you don't have to. Okay, we know. I know when we were doing a limited and access reagent, we always do it in grams because that's the nature of it. That you guys are always measuring these stuff in grams, but mole is really the same thing as grams, just to the ratio of the molar mass. So you can do your comparison using mole. And watch what I'm going to do here. I'm not going to change these guys to grams. I'm going to leave it as mole, and I'm going to pretty much do the same thing, but less step. So let's start with this to work with. And let's see, with 0.9 mole of calcium chloride, how many mole of Na2CO3 will I need for this reaction to go to completion? So let's do that right now. So 0.9 mole of calcium chloride. Okay, the ratio is 1:1, which means for every mole of calcium chloride, I need a mole of sodium carbonate. Moles and moles cancel, CaCl3 and CaCl3 cancel, and your answer is 0.9. Now, what that means is that with 0.9 mole of CaCl3, you need at least 0.9 mole of sodium carbonate. Now let's take a look. Oh, I'm not really given 0.9 mole of sodium carbonate. What's in here is 0.87 mole of sodium carbonate. I need 0.9. If all 0.9 here was to be reacted, well, it looks like because I don't have 0.9 here, which is what's in here, this has to be delimited. Let me say that again. Okay? You calculate that there's 0.9 mole of calcium chloride in here. And if all 0.9 mole were to be reacted, you need 0.9 mole of sodium carbonate. But in here, there's no 0.9 mole of sodium carbonate. You only have 0.87 mole of sodium carbonate in here. What that means, not all of these, will be reacted. There's going to be some leftover that are going to be unreacted. This is going to be excess, which makes this limited. Hopefully you understand what I just said. If not, rewind and just listen to it again. Okay? So because, there's less than 0.9 mole here, this will make, right here. Okay? Na2CO3 is limited. And you always use the limited reagent to find products. That's something you already know. So let's do that. Okay, let's answer this question. Now, you already found out that there's 0.7 mole of sodium carbonate. Okay, that's how much sodium carbonate is in here. So, if all of these was to be reacted, how many mole of this will be generated? Okay, let's do the stoichiometry. For every mole of Na2CO3, you get 2 mole of NaCl. Mole and mole cancel. Na2CO3 cancel. And what you're left with, as I said, I don't want to be doing this in my head today, is 1.74 mole of NaCl. And you stop there. Don't change it to grams because there's no need to. Because take a look at your answer, your formula right here. Okay, I want mole of NaCl, which you just got, divided by total volume, which you can find. So let's answer this question now. So mole is 1.74 mole of NaCl. Divide that by 0.3 liters plus 0.3 liters. Obviously, it came from here and here. Okay. So, what is the answer? The answer is 1.74 divided by 0.6. And that is 2.9 moles per liter. That is the concentration of NaCl. Okay? And that's actually the whole idea of solution stoichiometry. Okay? Obviously with this, I can be doing, many things that I can ask you. Like for example, I can always ask you, if given a certain number of this reactant, what is the concentration of this reactant for the reaction to go to completion? I can ask you something like that. Okay? And I will ask you something like that in the second example. Okay? We'll actually see this example in a bigger scope through acid and base chemistry later on, known as titration. But let's not do that right now. Let's do the same equation, because you guys are familiar with this. I'm not even going to put the states anymore. Okay, make this simple, 1-to-1 ratio. All right, I want to know what the concentration of this is. Okay, what I do know is that this is 20 milliliter or something like that. Okay, I know what the concentration of this is. This is 4.2 molar at, I don't know, 50 milliliter? The question is, can you find out what the concentration here is? Now remember, concentration is always about moles over volume. Okay? And in this case, you are given volume. You just want to know what the mole is to find out what this number. So if you're given molarity and volume here, can't you just turn that into moles? Use stoichiometry to find out the moles here, which is here, and then divide the two numbers. Right? How bad is that strategy? It's so awesome. You think about it. So let's do that. So let's find out what the mole is for sodium carbonate. So sodium carbonate is 4.2 moles per liter. Okay, multiply, of course, by 0.05 liters. Now, I don't really have to change it to liters if you think about it. I can do this 4.2 times 50. But if I do that, the moles will be in millimoles. Well, maybe it is a better idea to change it to liters, so you don't confuse yourself. So the answer, of course, is 0.21 mole. So you actually have 0.21 mole of this, based on the concentration and volume. Now you do your stoichiometry that you love. So 0.21 mole of Na2CO3. Because you know that 1 mole of Na2CO3 is equivalent to 1 mole of CaCl2. Moles cancel, sodium carbonate cancel, and the answer is 0.21 mole of calcium chloride. Okay, so for all of these to react with this, you need 0.21 moles of calcium chloride. Now, you want to know what is the concentration that you use. So this is where you go back and go back to the concentration equation. So mole of CaCl2 you discovered is this. That is 0.21 mole. The volume, okay, of this reactant is given to you, okay, as 20 milliliters. So that is 0.02 liters. So the answer is 10.5 molar. That's the answer. That's this. Pretty easy question. You just have to know what number to use in what situation. Okay, so you really have to know the question before you answer. It's not really just plugging numbers into an equation and you call it it. You have to know, what are you looking for? Okay, in this case, you're looking for the original concentration of calcium chloride given the volume. Okay, given to what is being reacted with, because the idea here is this will go through completion with nothing left, no excess, no limited. All right, so with those two examples, that's all you really need, okay, to know solution stoichiometry. There's a lot of questions that I am going to assign for you to do, okay, but this is not it though. We will actually come back to all of these, okay, and make it meaningful by looking at acid and base titration, which is part of topic 8. Okay, so we're not done with solution stoichiometry. Oh, no. We will come back to this in a more meaningful way, in a way that is more popularly, investigated, okay? And it is a method of finding a known concentration known as titration method. So let's keep this at the back of our head, okay? Make sure you know how to do these two examples. If anything, I would, look at these questions from the beginning by pausing the video for question 1 and 2 and see if you can reproduce the answer on your own. And don't forget to do the questions I'm going to be assigning to you. All right, today's kind of short. I'll see you next time. Bye.